All right, we're given that sine of b equals 1/2, and side A has a length of 20. All right, so getting going on this, it's not an easy problem in this case, but I'm going to go ahead and start and just label sides and angles. I'm going to go ahead and say A is here, meaning that side A is going to be down here. B is on this side for angle, so B, the side length, is going to be on this side. And I'm going to make this a nice right triangle, so I'm going to say C, the angle is the right angle, and little c, the side length, is going to be the hypotenuse in this case. So as we get going on this, let's try to identify what we do know. Well, we do know that little a, is going to be 20. We don't really know a whole lot else besides that. All right, sine of b is going to be 1/2, and we could say to ourselves, well, sine from SOHCAHTOA is going to be our opposite over our hypotenuse, which is definitely true. Labeling this, that would be the opposite, right, across from angle B, and the hypotenuse is side length C. And A, we're going to label that as the adjacent side. All right, so you may notice that the one other additional piece of information we have, the adjacent side, doesn't fit into either the opposite or the hypotenuse. So we run into a bit of a problem in this case. That makes this a bit of a tricky problem. So what I'm going to do next is go ahead and say, all right, 1/2, that ratio, that's actually a pretty nice ratio, right? That shows up in our common angles as we take a look at our chart. Hopefully from here we can say to ourselves, well, I know that sine of angle 30 degrees always produces 1/2. All right, in my classes, we always kind of use a handy-dandy trigonometric function chart. All right, so angle B is going to be 30 degrees based on sine of B equaling 1/2. So I'm going to go ahead and label this as 30 degrees is going to go in this corner for B. All right, from there, what I'm going to do is suggest that we involve one of our trigonometric ratios that's going to get that A equals 20 involved. All right, so you may notice that A equals 20, that's our adjacent side length. So I want to get either cosine that has the adjacent or tangent that has the adjacent involved as well. All right, I'm going to go ahead and say, let's get cosine involved. So let's say cosine of 30 degrees, so cosine of B, is going to be our adjacent, 20, divided by our hypotenuse, C. Okay, so just SOHCAHTOA, it's the middle section there. From here, we still need to solve for C, so we have a little bit of work to be doing here, but I don't think it should be too bad to solve for C. Let's go ahead and multiply both sides by C. Can't solve for it while it's stuck in the denominator. So we have C multiplied by cosine of 30, but cosine of 30 should be one of these known values. All right, that's going to be square root of 3 over 2. And on the right-hand side, by multiplying by C, we're going to have isolated the 20 on one side by itself. All right, what remains is still getting C by itself. But what we can do is we can multiply both sides by 2. That'll eliminate our fraction on the left-hand side. So we still have C multiplied by the square root of 3. But on the right-hand side, we're going to have 20 times 2 makes 40. So we're almost there. We still need to get C by itself. We need to get rid of that square root of 3 that's connected with multiplication. So we'll use division on both sides to isolate that. All right, so C, side length C, is now on one side by itself. We can clean this up a little bit on the right-hand side by going ahead and rationalizing our denominator. To do that, we'll try to get rid of the square root that's in the denominator by multiplying both numerator and denominator by square root of 3 over square root of 3. So what this is going to give us for C is going to be 40 multiplied by square root of 3 for our numerator. And then square root of 3 times square root of 3 makes square root of 9, or 3 in our denominator. Okay, so labeling a little bit more here. We can say side length C is 40 square root of 3 all over 3. And now all that remains is we need to find our opposite side length A. All right, so to do this, there are a couple different ones we could pull out. We want to get either the opposite and the hypotenuse involved, or the opposite and the adjacent involved. It really doesn't matter. We can do it either way we so choose. Yeah. So let's go ahead, and I'm going to suggest we use sine of 30, which is going to be opposite over hypotenuse. So in our case, opposite is b, still unknown, over the hypotenuse, which we just solved for, 40 square root of 3 over 3. Remember, our big fractional division bar is going on right there. All right, from here, a little bit of solving down needs to happen, right? We're trying to isolate the b, the one unknown here. So let's go ahead and multiply by 40 square root of 3 over 3 on both sides. 40 square root of 3 over 3. On the right-hand side, all of this goes away, and we're going to be left with b on the right-hand side all by itself. From here, we do have our 40 square root of 3 over 3 comes along, but we can replace sine of 30 degrees with 1/2. Again, that was one of our known values. One of the two pieces of information they gave us at the very beginning was they said sine of b is 1/2. So just filling in that same information. From here, almost there, multiply numerators, we get 40 square root of 3. Multiply denominators, we get 3 times 2 makes 6, which will reduce down a little bit. Both numerator and denominator are multiples of 2. So we can say 20 times square root of 3 over 3. And that's our value for b. I'll go ahead and label it up here. 20 square root of 3 over 3. No more reducing down needs to happen. So we have found all the side lengths. If we wanted to find all the angles, well, A is going to be given by, so angle A would be 90 minus 30 degrees, is going to be 60 degrees up here. I don't think we were asked for that piece of information, but we could have found it if we so chose. Remember, all the angles in a triangle always have to add up to 180 degrees. We already used a right angle, which is 90 degrees, so that's why I did 90 minus 30. So if this helps out, good luck as you're using given information and trying to find side lengths.